Hello, so we're going to be doing test corrections today on Unit 2B. So I'm going to have to zoom out a couple times because it's a little bit bigger. Okay, so our first one says, consider the incomplete flowchart as shown. Given CD bisects angle ABC and angle 1 is congruent to angle 2, prove that triangle CDA is congruent to CDB. So we're proving that CDA is congruent to CDB. And it wants us to fill in the parts. So remember, when we talk about flowchart, they have to go in order. So when we're looking at this, sorry, trying to get some stuff out of the way. When we're looking at this, when we see bisects, we know that we're gonna have to use the definition of bisects in B, because when we have an arrow pointing, we're using what's in here. So B has to have the definition of bisector, so it's not gonna be C or D. Now you have to figure out what it bisects. So if CD bisects angle ACB, that means it's going to make angle ACD congruent to angle BCD. So those say the same thing. So check, 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 check. Well, we also know that angles 1 and 2 are congruent, so that's a given. That's a double arc, but it doesn't look like it. And the last thing we use is the reflexive property. So we proved this by angle, side, angle. So this is going to be answer choice B. So you're just filling in the missing pieces. Remember, we're going to go in order. If we have a definition to use and there's an arrow, we're going to have to apply that in that next problem. It's easy if you mark on your screen or just try to follow along to figure out which proof that we're going to be using. Okay, so we're going to move on to the second one. Second one is also a flowchart proof. So it says, consider the incomplete flowchart proof as shown below. Given that angle E is the midpoint of BD and angle or segment AE and segment EC are congruent, prove that triangle AEB is congruent to triangle CED. So I'm going to go ahead and it says we're proving that E is the midpoint of BD. So this is the midpoint of this right here. So we know based on that those are going to be congruent by the definition of midpoint. So once again, we're using midpoint here. So we have the definition of midpoint. We have to apply what we're using. And we know that BE is going to be congruent to DE based on that definition of midpoint. So we're going to go ahead and get rid of these two because they're not saying BE and DE. These two right here are. So we don't really have to do too much here just because we already see it, but they're the same. So we know that this are going to be vertical angles. So check, check, because they're exactly the same. Now, the other thing I told us is it says BAE, oh, that's the one I just saw. Line segment AE is congruent to EC. So while looking at this, we have a side, an angle between the two sides, so side, angle, side. Remember, for a side, angle, side to be our reason, the angle has to be directly between those two sides. So that's side, angle, side, which is here, not angle, side, angle. So that's J. Okay, I'll go ahead and erase. Consider the flowchart proof and the corresponding two-column proof. Given the isosceles triangle FGH with a base of GH and a median of EF, prove that GFE is congruent to HFE. So we have the isosceles triangle. We're going to use the definition of isosceles triangle to say that our line segments are congruent. Okay. If EF is the median, that means GE and HE are congruent because they're both going to be right angles by the definition of median. Right angle is congruent to a right angle. And then it says that EF is based on the reflexive property. Okay, so I'm making those marks on there so that we can see it, but we actually don't really need to because we're just corresponding. The proof is already written. So we're just going to follow our parts here. So definition of isosceles triangle right here. So that's GF equals HF. I believe I kind of wrote on it. It might be GE. I'm going to erase it. Yeah, GF is congruent to, make it a little bit smaller. So this says GE, this says GE, we're down to 2. And then definition of median is right here, GE and HE. GE and HE, GE and HE, okay? And then part 5, EF, that's the reflexive property. And so, oh, okay. So this says GEHE. This says HF. This one said, and this was given. That's the reflexive property is the next part. I was looking at the wrong line. So we're just using the process of elimination. Given is not what this statement says for part 5. Givens were these two right here. So we're filling in those blanks. Okay. Our next one, consider the incomplete proof shown. Given AC is congruent to CE and BC is congruent to CD, prove that angle B is congruent to angle D. Okay. This is really simple. It says, what step would be CPCTC? That means corresponding parts of congruent triangles are congruent. This would always be your last step. You prove the triangle is congruent, and then once you prove that it's congruent, which is what we did right here, you could say anything is congruent by CPTCP. So that's going to be J. That one doesn't involve any real work as long as you are reading it fully. Okay. Number 5, consider triangle DEF, where measure of D is 4x minus 5, measure of E is 3x plus 15, and measure F is x plus 10. What is the value of x? This gives us every single measure of a triangle, and we know that triangles equal 180. So we're just going to use system solve to solve this one. It's real simple. Let me go up to my calculator. We're going to go to a calculator screen. I'm going to do menu, algebra, solve systems. Not system solve, numerical solve. And we're going to go ahead and we're going to type it in here. We have 4x minus 5 plus 3x plus 15 plus x plus 10 equals 180, because that's how much a triangle is. And to solve for x, you hit comma x and press enter, and it says 20. So x equals 20. Now, when you're typing this in on your computer, you're only writing 20, so you're just writing this. So 20. Okay, I'm gonna go ahead and clear. Our next one says, suppose A, B, C are exterior angles with vertex B, or A, B, and C have an exterior angle at vertex B. So we're gonna have a triangle. Okay. Then we're gonna say this is A, this is B, because that's where the exterior angle is, and this is C. Then we say that A is 3x minus 6. This is 6x plus 12. And this is 12x minus 24. But that's not it. So we're going to have to solve for x. Then it says, what is the measure of the exterior angle at vertex B? So we want to know, we're looking for this measure here. So we're going to go ahead, we're going to use system solve, setting these equal to each other because that's what the rule is for exterior angles. So algebra, numerical solve, 12x minus 24 equals 3x minus 6 plus 6x plus 12, comma x. It says that x equals 10. Now, 10 times 12 is 120, minus 24 is 96. And if you're not sure, just plug it in. 12 times 10 minus 24, 96. Okay. Sometimes it helps to draw this stuff out. Okay, consider the incomplete paragraph proof as shown. Isosceles ABC and triangle, isosceles triangle ABC with AB congruent to BC. Let D be the midpoint of AC and draw BD from the given statement and the definitions of isosceles triangle. AB is congruent to BC. Also, since D is the midpoint of AC, since we're saying that D is the midpoint of AC, then blank. So by the definition, since D is the midpoint, we know that AD and DC are going to be congruent. Doesn't matter the way you write it. So we're down to those two. By the blank property, we also know that BD is congruent to BD. Well, that's going to be reflexive. That's this line right here. It looks horrible, horrible, horrible. That's reflexive. So they both say reflexive. Also, then it says, therefore, AC is congruent to, A is congruent to C because the corresponding parts are corresponding triangles. So we're filling out this. So we know sides, these sides are congruent, these sides are congruent, this side is congruent based on the reflexive property. So that's side, side, side. So we have a side, side, side. So B. If ABC is an isosceles triangle, which statement explains whether there's enough information to prove that ABD and CDB are right angles? Okay, so there's a couple of things that we would need to know in order to say that those are right angles. We would have to know that was like a perpendicular bisector. We would have to know if it's a median would be perpendicular. We have a lot of stuff to prove specifically a right angle. It's not the same to prove that something is just congruent. So the first answer says, no, it is not known if A and C. So if ABD and CBD cannot be proven to be congruent. So with an isosceles triangle, what we know is we know these two sides are congruent and these two angles are congruent. We also know with the reflexive property that this is congruent. Nothing else can be determined here. We don't know if this is an angle bisector. It does not say that anywhere. We don't know if this is a midpoint. And we don't know if this is perpendicular. So this is not a valid proof because it would have to be side, angle, side, but the side would have to be right here because the angle has to be between the two sides, or the angle would have to be here. So we're going to write through these answer choices. No, it is not known if angle A and C. So ABD and CBD cannot be proven to be congruent. Well, if this is the base, then we know that those are congruent, so that's not true. No, it is not known if BD is an angle bisector. That's true, that was not given. Of ABC, or if D is a midpoint. We also don't know that. Thus, ABD and CBD cannot be proven congruent. Those are both true statements, but let's keep reading. Yes, angle ABD and angle CBD by side, angle, side. Once again, we've shown what we can prove. For this to be side, angle, side, the side would either have to be here or the angle would have to be here. We do not know those, so that is not true. Okay, and then, yes, ABD and CBD by side, side, side. We don't know that third side because we don't know if it's a midpoint. We would have to know it's a midpoint to say they're congruent. So the only one that's true is G. Okay. The equation shown represents two altitudes of triangles. What are the coordinates of the orthocenter? So not just a fancy way of saying what's the intersection. So we're going to open up a graph. We're going to graph it. X plus 1, because you can't put anything after the equal sign. Negative 2x minus 1. Enter. Okay. So this is the intersection. To find that, we're going to go menu, analyze graph, intersection, left side, right side. And then we're gonna look at these. So they're both decimals, which means they're both gonna be fractions. Whole numbers are out. Then negative, positive. This is negative, negative, no. So C. Okay, we're almost done here, but we're gonna get to the ones that are a little bit harder. We're about to go to winter celebration, so I might not get to finish this, but I will try. What are the coordinates of the orthocenter of the triangle with vertices 4, -2, 4, 6, and -2, 4? So I'm gonna figure this out. 4, -2. I'll move this over a little bit. Okay, first point is 4, -2. That's A, and then we have 4, 6. 1, 2, 3, 4, 5, 6. So this is A, and this is B. Okay. Then we have -2, 4. -2, 4. Okay, so this is actually not going to be too bad for us. It already gives us a starting point, and I'm going to make that as a line just so we know. It says our x value is 2. That's what it already tells us. So we know that the orthocenter at some point in time is going to go through the value 2. That's our x value. We're just looking for the y value. So I'm just going to make that line because that's given. So we're looking for where they cross, and they're going to cross at this point somewhere. So for orthocenter, we find the perpendicular line from the point. So we find our easiest slope to start with is horizontal or vertical, and then it leaves the vertex of the other one. So if we're looking at AB, we see that we have a vertical line, so that our perpendicular line is going to be horizontal, and it's opposite of angle C, which I forgot to write C on there. So that means this line is going to be coming out of here as a vertical line. I'm sorry, as a horizontal line. And that actually gives us our answer right there. We don't have to go any further because we already know our x value is going to be 2. So we're really just looking for our y value, and our y value is going to be 4. So that one seems complicated, but it's really not. So you're just going to type in only the y value, which is 4. So type in 4 there. Okay, we're on question 11 now. Consider a triangle DEF with a centroid at G and the median of EH. What is GH if EG is 3x plus 4 and GH is x plus 10? So we know triangle. Oops, I was trying to do the line tool. That's fine. So A, B, wrong letters. D, E, F, and a centroid. So remember, we find the midpoint and we connect it to the corresponding vertex. Does not have to be perpendicular, just the midpoint. 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 Okay. The centroid is G. And then it says that we want to know EH. So this is H right here. So GH is a smaller portion, and GE or EG is the bigger portion. So you know that this is 2 times GH based on drawing out your picture. So we're going to have 3x plus 4 equal 2 times x plus 10. That's how we're going to solve that and find x. That's step 1. Okay. So calculator, menu, algebra, numerical solve, 3x plus 4 equals 2, parentheses, x plus 10, close parentheses, comma, x. And it's kind of hard to see. It says 16. So x equals 16. Then it wants us to find GH, which is 16 plus 10. 16 plus 10 is 26. Okay. Almost done. Just a couple problems left. I'm going to go ahead and clear that out. But that one, I highly suggest drawing them out to try to figure out which one's bigger. Because the bigger side is going to be the 2x, and then the smaller side is just going to be the x. Okay. So we have another one about centroids. So we have triangle ABC. I'm going to draw it out again. Midpoint there, midpoint there. And remember, I'm just eyeballing it. It might not be perfect. Midpoint there. Okay. So this is, let me label it A, B, C. Centroid is point E. And this is point D. So it says, what is the length of AE? We're looking for the 2x part. And this is x. If AD is 30. So it's giving me the full thing, 30 for the full thing. So when I have the full thing, this side, we have 3 x's. So this is 2/3 x. So that's 2/3 of 30. 2 times 30 is 60, divided by 3 is 20. So H. Okay, like I said, I do not know if I'm going to have time to finish this. I've got, it's 2 o'clock, but I'm going to try. So we got 13 left. Okay, what are the coordinates of the centroid of the triangle with vertices 3, -1, 2, 5, and C, 1, 2. So this is going to be the same thing. So 3, -1. 2, 5. So that's A. 2, 5. And 1, 2 for C. Okay, I'm not the biggest fan of this one, but some of those are really easy to find and some of them are not. Okay, now let's see what 3, -1, 2, 5, 1, 2, and it says 2 for the y value.
Please pardon the interruption. Students, you will need to leave your belongings in your classroom. Anything you take with you, you will be responsible for. Please wait for the announcement to release all eligible students to winter celebration. We will release by grade level. Also, teachers, please make sure you are actively watching these students on campus.
3, 3.
Also,
this is the midpoint.
At 3:55, teachers, we will direct students back to 5th period.
So that point is 2, comma 2.
For dismissal. Again, please wait until we release.
So that's a 2.
Grade level. Thank you.
Okay, so that's 2. The only reason is because I found the midpoint here. It went down 3. Well, it really went down 6/1. So because of that, it was going to go down 3.5. And then I follow that to the vertex, which gave me that 2, comma 2. So you're filling in the number 2. Okay. Consider triangle ABC with the end center of D. If measure of ABC equals this, measure this, what is the measure in degrees? Okay, so C is going to be, these are going to be congruent. So because they're congruent, I was gonna draw it out, but we're just gonna go ahead and use our calculator because I'm running out of time here. So menu, algebra, numerical solve, 3x plus 54 equals x plus 31, comma x. I think I typed in something wrong. 3x plus 54. I think I messed up in there.
Please pardon the interruption. Sixth graders, you are released. Thank you.
Looks good. I don't think it should be. Okay, give me 1 second. Okay, I'm gonna draw it out real quick. So we have A, B, C, A, B, C, with an end center of D. Okay. Then, I don't think that's equal distance apart, but I tried. Here, 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 here. Okay, let's see what it's giving me. It's giving me A, C, B. It's giving me this angle. Then it's giving me A, D, no. A, C, B. B is here. It's giving me this full thing. Okay, so that's what that's doing. I was confused on. So there's gonna be, that's 1/2 of it. So this one is the B, which is the big one. So it's gonna be multiplied by 2. I was wondering why I was getting a weird number. So X is 8. And we want to know ACB, ACB. 3 times 8 plus 54 is 78. Okay, so that's G, 78 degrees. I'm running out of time. They're already making announcements for people to go. Let me see if I can get to the last one. Consider triangle ABC with circumcenter P as shown below. If BP is 12, so this is 12. What is the value of BD? Okay, so these are 12. Oh, BC. BC is 22, which makes this 11. And we're looking for this value right here. It's 11. I was overcomplicating it because half of BC, since those are congruent, because it's a circumcenter, is going to be 11. So that's B. Okay, I'm gonna go ahead and end this and I'll get it posted. Y'all have a great winter break.